Welcome back to Track 3 Cloud of Python WebConf 2021. My name is Josh Qualls. I am the LoudSwarm account manager here at 6 Feet Up. And joining me today is Erez. Erez is going to be talking about serverless and microservices monitoring in an IoT world. Super exciting. Very excited for this talk.
Hi, everybody. Great to be with you here today. We're going to focus today in this talk on four topics that I really like personally. Serverless, microservices, monitoring, and IoT. So we just took those, put them all together, and built a session. So we're really excited about this today. Great to be with you. My name is Erez Berkner. I'm a CEO and co-founder of Lumigo. We'll dive right in. Please feel free to ask questions in the Q&A part. So we're going to cover 5 main topics today. Number one, we're going to talk about the cloud, the modern cloud application. What does it look like? What is it composed of? We're going to talk about IoT and serverless and how they work together. And then how can we get observability into modern cloud, which is one of the biggest challenges. We're going to take 5 minutes and show you how this actually looks like with a real environment running observability of modern cloud services. And we wrap up with a case study of an amazing application done by Medtronic, which is heavily using microservices and IoT. So we're going to dive deeper into that case study and learn from it a bit. So let's start with the modern cloud application. And I want to make this very simple. Like everybody has its own definition for modern cloud. And for the sake of this presentation, I want to talk about modern cloud that is, like to call it a mix of serverless and microservices application. So today, when you build an application which is based on the basic cloud native services, you have 3 types of services you use. One is compute for things like function as a service and containers as a service and managed containers. And this is your compute part. Other are managed services working like based on APIs. So it can be from databases to manage queues to manage web servers. Apologize, I will be focusing on a specific cloud vendor today with examples, but this applies to all cloud vendors. So I'll be talking mostly on Amazon since they are the most common in this environment. So that can be DynamoDB and API Gateway and Kinesis and S3, and basically all the services that you don't need to set up server for. And there are third-party applications to do specific things. So if I need to do payment, I will use Stripe. If I need to do, or PayPal. If I need to send SMS, I will use Twilio. But the essence is that with these 3 type of services, I can basically build today any application and have absolutely 0 servers and 0 need, or almost 0 need to maintain scalability, to maintain high availability, because this is taken care of by cloud provider, by Amazon, by Microsoft, by Google, by Twilio, by Stripe, by everybody else. And they usually doing better job at this, and at least than me. So that's what I call modern cloud applications. And it's important to understand that this model, this architecture that we see growing in many, many organizations, startups and big organizations, this is actually different. It's not just like a new services and which you combine, but it's very, very deeply behaving differently than other old style, I would say, server application. So think about a checkout request. I click on a checkout, then services start emerging, span up, do their thing, and then go to sleep or stop functioning. This is called like the ephemeral part of that is what really makes the difference. So you no longer have a server that is always there that you can connect to. And that provides great things like cost efficiency and reduced maintenance and attack surface, but it also provides some challenges that we need to take care of. We're no longer in the world of 3-tier application with web, business logic, and application. In microservices, we're talking about hundreds, sometimes thousands of components. Each of those has a specific role, and you combine all these different services into a bigger application, and this is how you model your application today. And at the end of the day, when we're talking about the managed services of the modern cloud, you really don't have a server you control. So as I mentioned, you cannot SSH to a server to check what's going on. You cannot deploy agent that you used to help you in the past with security, with monitoring, with deployment. So it requires different approach. And one of the biggest challenges in this world are debugging and monitoring. And part of the session will cover that. But before diving into how can you actually run that in production, let's briefly think about IoT and serverless. And IoT and serverless really makes sense. We see a lot of companies, IoT-based applications that are using serverless as their backend. And mainly, these are I would say the characteristics of serverless that really comes to play with IoT environment. So the ability to spike, to scale when you deploy another 5 million devices out there without any need to really define something new, to configure new servers and auto scaling groups and all of those that relate to servers. This is a game changer for that serverless bring with it to the IoT world. Also ability to scale to zero. If your IoT has some restrictions, you'll be able to scale to zero and save a lot of cost when they're not operating. Edge computing is another big one, especially for global, worldwide deployment of IoT devices, since they require short round trip, but at the same time, they are very widely deployed. Serverless, by definition, is tuned for asynchronous processing, and IoT gains a lot from being asynchronous because you basically send back the data, the metric that you need, and you're usually not waiting for a response. And serverless is a great match for that. Most cloud providers have IoT backend managed services. So it's kind of like taking Stripe for payment service. You don't need to set up everything that has to do with the financial part. Same goes for IoT by cloud provider, AWS, Microsoft, all of their services that basically allow you to use either HTTP or MQTT to connect with their service and without adding and building your own IoT backend code to get the request. QoS is also very easy to do as a gateway in front of your serverless services. So this is another thing that IoT is good at, needed. And event-driven, that really defines the execution model of IoT devices, is also the core of serverless architectures. So an event is happening, and that's what triggers the execution. And that's what IoT sends, and that's what serverless receive, and that's what starts execution of a serverless backend. So when we think about this backend of serverless for IoT, and we want to think about how can we actually run it in production, and how can we make sure it's operating and with the right definition, with the right latency, with the right amount of minimum amount of errors and issues. Basically, we need to take into account three main things. One is because we talked about how distributed microservices and managed services are, and because there are hundreds of those, a critical part is distributed tracing. And not just distributed tracing that will basically allow you to connect the dots, understand how services are communicating with each other. It's not just about that, it's about that being automated. Because when you have hundreds or thousands of microservices doing that manually and chasing after every new service that pops up is literally impossible in large organizations. So that's one critical point for observability of that backend. A second point is the ability to drill down to a specific service out of the 100 services that you identify that has a problem and be able to understand what happened in a specific transaction, in specific request that failed. What were the different logs, the different environment variables, the different debugging information that you need in order to understand the root cause. And third thing that is very common in microservice environments is latency and latency breakdowns. Every service can now create a latency issue for you and become a bottleneck. And if the end goal, the end response time of your application is low, you now need to figure out which one of those 100 services is the one that actually creating this hiccup. So having an understanding of the flow and ability to break it down into a timeline that tells you where are you spending your time in this specific request, in this specific transaction that actually hiccup, this is critical for monitoring. So you have different ways to do that. You have tools by the cloud providers. AWS has some like CloudWatch and X-Ray and some other tools. Microsoft have their own tools. There's some open source you can integrate doing that. If you want to check this out, you should look at Jaeger, which is a open source tool doing that. And generally, there's an open telemetry framework of doing distributed tracing in such environments. Or you can use applications, third-party application, and vendors doing that. And specifically, I want to share what we're doing in those environments. I didn't mention what Lumigo is doing at the beginning, but Lumigo is a serverless observability platform. It basically gets metrics from the cloud vendor, things like how many invocation, how many failures, what is the highest latency service that you have, and so on. That's from the cloud provider. Generating traces, so ability to understand what is the flow of the request, what's getting into every service and getting out of every service and connecting the dots, and gathering logs. These are the things that every monitoring platform should gather in order to allow you visibility to what's going on in production. And specifically, we do that automatically by our SaaS platform in Lumigo, and that's how we allow our users to monitor and understand what's going on in their serverless backend. So I want to take you to an example of, again, I'm discussing different tools. You can implement that yourself, but essentially, what are the things that you need to have in a production environment in order to be able to observe a specific request coming from your IoT device? So first and foremost, you need to have visibility. So you need to know that when something will fail, you will know about it. So let's suppose there's a serverless function over here, a Lambda. If this fails, you want to get an alert on that. If we think about IoT world, that would probably be, you probably wouldn't care about a specific metric that failed, but a bunch of metrics. So you probably need to have alerts on things like 5% of your requests in the last 10 minutes failed. This would be the thing that you want to have in place. So understanding that something is happening, but not just, you need to monitor the right thing, not just like you have a failure, but also like you're managed service is about to reach some critical threshold. It can be like a concurrency threshold. It can be like memory threshold, duration threshold. The threshold that we used to have, like CPU and IO, are different in the modern cloud. And therefore, you should have those alerts baked in and not have like the generic CPU and memory alerts in place. So try to have a specific alerts for the service that you use, and then you can hook it up with Slack, PagerDuty, or whatever, allowing you to know about increase in failures or a specific resource like Lambda concurrency. Second thing that you need to do once you understand that there's an issue is to understand what is this impacting. Because it's very different if it's impacting, a critical IoT device that is working on payment or a different IoT device that is doing something that is not business critical. And the ability to understand that in microservice environment derives from the fact that you can connect the dots. This is a distributed tracing we talked about. Because the same service that pulls something from database can be serving multiple applications, and it's a microservice. It only knows how to pull something from database, and this is why you need to make sure you understand what is the path and what is the actual customer-facing API that is impacted. Especially since once you understand what's going on, you understand that this is your architecture. So you really need a way to visualize this and understand what's happening, but in a very specific way. You want somebody to be able to tell you the story of that specific request. So going across all these services, this is one request that had an issue coming from the process payment service or API. That's critical. We need to make sure we know how to fix this. And then we move from, okay, I know the issue, I know it's critical, to how do I actually debug that? And in order to debug in a microservice environment, you need to be able to go and look at the different services that this request went through. Because in a microservice environment, opposed to a monolith environment, the root cause is many times not in the same service that failed. So if this Lambda, for example, failed, the problem can be originated somewhere along the way because the services are so distributed. So you need to have the way to examine and go upstream and service by service understand what were the input, the outputs, the environment variable, logs of every service in that specific request, maybe out of millions of requests. We're going to mention Medtronic use case in a second. And that's what you need to have in order to identify the issue that might reside in this service, for example. Let me jump over this real quick. I want to take you to a quick demo of how this actually looks like in a live environment. So let me share my demo with you. We'll stop for just 1 second to pray for the demo gods for this to work. I had somebody tell me earlier today that I'm really adventurous doing a live demo.
Live demos, they'll get you.
yeah. I want to prove them wrong. So
please, demo gods.
Thank you. So this is an example. Again, I'm showing here Lomigo. It can be any platform that you're using, but the essential part is starting by having an alert about things that are critical, having the visibility. Things like how many requests or invocation do you have, how many failures, what are the ones that are most failing, what are the ones that have specific latencies or issues or costs. So there are different things that you need to monitor in those environments. I mentioned timeout and durations. Cold start is another very common thing when we talk about specifically serverless within the modern cloud. But the thing is, you're not going to spend your time looking on dashboards. So having alerts in place for all of this is critical. Connecting that to Slack, to PagerDuty. And let's try to follow what what happens when something goes wrong. So just like I mentioned in the slide a couple of minutes ago, first of all, we want to get an alert on that. So let's suppose we got an alert on this specific function that is failing 43% of the time in the last 14 days. Of course, this should probably be like in 10 minutes alert and not 14 days, but bear with me. So we got an alert. We know about a specific function. We want to know what is the customer-facing API. What is the priority of this? And this is where we move from monitoring and alerting to the actual debugging. And in the middle, we have the distributed tracing that we talked about. So if I click over here, this takes me to the specific failures of that specific function. So let's filter according, let's see all the issues of that function. And we can see one by one, these are the failures of this function in the last 14 days. So let's pick one of those in order to drill down. And this is where understanding the priority, understanding what is the customer API happens. And this is the heart of every distributed tracing system. This basically takes you from a specific service to this, to the map of what happened. So what do we see here? We started from this one. This is the Lambda that failed. And as I showed you in the slide, you can immediately understand what is the customer-facing API. This is critical. I need to fix that. So now I want to start the journey to understand why did this fail first and foremost. And this is where you need to have the additional debugging information we talked about. So in order to understand that, in our system, you can just click and get a lot of debugging information about that specific transaction failure. So it took 116 milliseconds in this region. There are different tags that we generate automatically, but the essence here is this is a stack trace. This is a problem. Details write ID cannot be an empty string. So that's a failure. It's a very detailed definition of a failure. You can see the stack trace and the parameter of the stack trace. But you can see the event that triggers the Lambda, the environment variables, all of this are, and the logs, all of this are things that you should have in place when you want to have a distributed tracing and debug using it. Again, you can do it yourself. You can create this using OpenTelemetry. It requires coding, it requires logging, but you can get to this and beside the visualization, but I think you get the point. And of course, you can use third-party tools like Lumigo, where you use it without any code changes. It's all just by APIs and AWS integrations. Specifically, just let's see, this is a details, write ID cannot be an empty string. I see that the event that actually triggered this Lambda, write ID was indeed empty. So just by that, I can understand the problem does not reside within that Lambda. It's somewhere upstream because this Lambda is getting wrong info, wrong data. So let's go upstream. We can go to this. This is the event bridge. It's a managed queue by AWS. Clicking on this, and we can see what was the actual message of event bridge. We can see in the queue, the message was still empty. So basically going to every service, whether it's the databases like DynamoDB, where you can see the actual query and the results, or we talked about external services like Twilio, where you send SMS, and so you can actually understand what's happening over here. So this is kind of the essence of how you can go and start debugging while having on the right-hand side, in parallel, all the logs, 51 logs that are specific to this transaction across all the services. Even if I have 1 million logs at the same time, this is maybe the biggest problem of our modern era of being flooded with noise and data. And distributed tracing allows you to pinpoint what are the specific logs that you should read, like a story on this view. We also mentioned a latency breakdown. So this is not a latency issue, but you need to be aware and able to see. And again, you get this in all those platforms, from cloud vendors to third parties to the open source tools, something like Timeline View, where you can actually see where are you spending your time in this transaction. And specifically, you can see that there's a huge gap over here that nothing is happening in this. So understanding what's going on, why is this gap happening? Specifically, it's a failure that tried to retries every 60 seconds, or 60 and 120 and so on. But maybe you need to shorten that. So this is kind of a critical view to understand across all the services, where are my latencies? So I want to stop over here, and if there are specific things that are not clear, I'll be happy to take some more Q&A at the end. But I wanted to show you how this looks like in production, how you can run this and get the visibility that you need. I think one of the things that I've seen is that most people don't understand that they can do more than just getting logs, because that's like the most common way to debug today. And I think like having awareness, it's not about a specific tool, it's having awareness that there are ways to do distributed tracing and get much more. So that's a game changer for this environment. So first of all, thank you for the demo goats. I think that I won some bet over here internally in the team, so celebrating this. I want to take you to a case study that we're actually now in process of publishing with a company called Medtronic. Medtronic is one of the biggest healthcare providers in the US. 30 billion 30 billion company, and they are having over 100,000 employees in the US, and they started their serverless journey. Where their environment is mostly serverless today. Some managed containers, but definitely modern cloud as I defined it. And they started their serverless journey back in 2017. And I'm talking now about the diabetes department. So essentially, they are doing a lot of data ingestion from IoT devices, from smartphones that generates events for them, from application and from actual diabetes insulin pipes that actually are helping patients in the field. And they basically started with this 2017. They started with basic configurations for smartphones, and added more and more applications to serverless. So the serverless environment grew, the complexity grew, and today they started with around 10 million invocation or 5 million invocation back in 2017. I personally met the owners of this project in 2018, and today they have over 1 billion requests going through the system every month. And most of them are serverless, almost 100% are serverless. And the thing is that they have multiple devices that generate multiple sources. So they deploy all these devices around the world. They have edge services gathering the information in an asynchronous way, and they send this information into their backend. It's an AWS-based serverless architecture. These are kind of the trade-offs that from their experience. This is, by the way, their slides. I'm sharing this with you. It's a part of another webinar that we're having, but this is their experience with the modern cloud and the managed services. About the trade-off, like having ability to, we talked about infinite scalability and without the need to maintain and manage. Ability to do parallelization and distribution of the services. So every service can scale on its own. Every service can use a different, even runtime They have different services in different runtimes according to what the teams decides. Of course, having no servers and having ability to do precise scaling. So when you have new IoT devices, you pay exactly for what they use in the event that they trigger, and you don't need to have servers up and running, doing nothing, waiting for scale to happen. On the challenges, this is extremely distributed. They have hundreds of services and therefore very hard to monitor and debug for the reason we mentioned. They actually kind of lost real track of what is a function flow end to end because they have so many services. And this is a challenge for them to understand their function flow. Goes back to visibility. Cost forecast is another thing that is very common in modern cloud because understanding, it's no longer about, I buy this amount of servers and that's what I need to do. Because it's not even about I'm going to rent this server for this month. Because if you have a spike now, you're going to pay 5 times more for that spike. And that's good because you want to serve your business. But cost becomes really challenging to do forecasting, especially when you have so many services. So you need to add up all those services, understand what served that application, what served the other application. So it became a mesh of services and payments and cost, and that's a real challenge in this world. And the ephemeral part of managed services is also a challenge for them because they needed to stop debugging the way they used to. They used to SSH into a server and look about what happened then, what were the events, how did the CPU and memory behave 2 hours ago. They don't have it anymore because the services they just like spun up and disappear. This is a couple of screenshots from, sorry, I didn't say. So they scaled their environment while scaling. They understood they have a problem. They couldn't get only managed with CloudWatch and X-Ray from AWS. This is where they onboarded Lumigo about a year and a half ago. And this is a couple of screenshots that they're showing from their environment. The ability to pinpoint a specific invocation out of 1 billion invocations is critical for them. So on identifying, show me all invocation where there is this internal error that they have of no such key. And then single list and being able to click and get to the actual transactions, that's a dramatic change for them in order to debug production. They're actually following a chain of asynchronous events, going from an IoT device, in this case, writing something to S3, triggering all these asynchronous events across things like queues you see over here, across web gateways. And the ability to track that is critical for 2 main things. One is for following the data, actually understanding this data point, what is the path it's taking across all the services, and following and getting, of course, the additional information about that specific service, and following the actual event across all services. They're using the timeline view for latency optimization, but also for cost optimization. That's very interesting use case because this is how they're able to understand what are they spending their time on, and they optimize not necessarily to reduce latency, but it really helps them to reduce costs. And another thing that I didn't really mention, but it is really critical in microservices environment, is to be able to connect different data sources of your production environment to understand what happened. And I'll give an example. We talked about metric and traces and logs all together. That's critical. You understand why by now, I guess, I hope. But also understanding of what happened in the environment in terms of configuration, deployments, who did what code changed. It's critical to correlate events that happens in the environment. So just as an example, they had an issue of cold start. This is from their environment. This is really recently. And they wanted to understand what happened. They saw this rise in cold start. They actually saw that, and at the same time, rise in cost. That's a really relatively small environment, but the idea over here is that they were able to correlate this with a specific deployment. So a specific deployment that happened over here created this impact of cold start or latencies. I'm not going to go into what cold start is, but this is an analysis that Lumigo provides automatically. And just by having this view and being to dive into the specific deployment that were made over here, they were able to very quickly understand what happened and fix that. So this is the high-level overview of Medtronic. They are actually planning to go much wider and to scale the 1 billion to dozens of billions a month, because they're gaining more and more application and scale into serverless. So that's a really vote of confidence in serverless architecture for IoT devices, in this case for AWS environments. I went very briefly on the Medtronic part. If you want to hear more, you're welcome to join this webinar we're having with AWS and Medtronic. That's on this Thursday. You can just go over here to this link and register. We'll be featuring one of the famous guys of AWS, Jeff Barr. He's their chief evangelist, who's gonna share his view on scaling serverless environments with IoT environments and the correlation between that. And we're going to drill down to the actual Medtronic use case in much more details. And you're going to hear it from much better speakers like Daniel and Jeff. So just for that, it's if you like the topic, that's an interesting webinar for you. So that's the high level of what I wanted to share. Just to summarize, IoT and serverless go together. IoT and microservices go together. So in this modern cloud that we're talking about, with no servers, with everything managed, if you're building an IoT environment, it makes sense to consider connecting this to a serverless backend. It really works together. And then going and making sure that you have the right monitoring tools in production. Monitoring that should be from day one, baking into that platform. So that's what I wanted to share. I really appreciate the time. If there are any questions, I do want to say that we really trying to help the community of serverless, of containers, of IoT, especially if they are together. So if there are any questions, if you need any guidance, please feel free to connect with me through Twitter, through LinkedIn, through my email. Really want to thank you for this opportunity and open this up if there are any questions from the audience.